this name. Anyway, so area load, my life load will be office, building, apply. I am ready. Your mouse or your arrow is ready to define where is your load. Just click on each area of your slab. Office, apply. I tried it but doesn't work. Why? Because I have three options. You can define your load by just click within perimeter of your area, or draw polygon area around the perimeter of your slab, or point to point draw of area. I need to click here, click, click, click. So you have three options to define how to define where is your load. So I will check the first option. Just click, apply. Just click at any point inside your panel. You will define area load for this area, like this. Just click, one click. We have stairs here. This area is empty area. So one more time, insert, loads, area load. Go ahead and choose what is the type of life load. Then you have three options how to define the area of life load. I will choose the first one, just click inside the pyramid. Once you are done, I'm ready. But before solving, you have to define something called load combination. Actually, in RISA floor, you don't need to define anything. Everything is defined for you. If you open just a spreadsheet load combination, or just click this icon, load combination, you will see we have 4 combinations. The first two for surfaceability, if you remember, surfaceability for deflection, surfaceability for cracks, surfaceability for vibrations, we don't care. But our concern right now, your strength, your design. So we have first combination, your dead load time 1.4. Second combination, your dead load time 1.2, your life load time 1.6. Okay? Just check. Then go ahead and solve. View, point, view, point. Let's start. I think if you open this one, yeah. Right now, we are in this step, slab results, load combination, loading, load combination, and solve. We did. Slab results. If you would like to show up the results on your slab, use this icon, very little icon, model display options, or just hit F2, and then go ahead for slabs. And we need color fill, and your color fill should be contours, and I would like to show up MZ, and then OK. I will see something looks like this. I cannot understand what you did exactly. Yeah, I know. You click this icon, you choose slab, you choose here color fill. We need to show your results as a color, and contour, and you define MZ, and you hit OK. But before hitting OK, we need to select something else. Slab, color fill, contour, MZ. I need to check here something called dead strength, dead plus life. This step is very important. Anybody remember what is the name of this axis? Z. Perfect. What is the name of this axis?
X.
Perfect. Anybody remember from last time I show up a video? What is the steer reinforcement in your slab? We have a steer reinforcement in this direction. That's right. And we have a steer reinforcement in this direction. Do you remember this video? We have reinforcement mesh. One in this direction and the other one in the direction. Do you agree? If you would like, if you are looking for reinforcement in the direction, we need to use MZ. If you are looking for steer reinforcement in X direction, what do you think? We are looking for what?
MX.
MX, perfect. If you open this icon, you have two options for moment, MZ and MX. If you are looking for shear, for example, Q. If you are looking for torsion, MXZ, both of them at the same time. But we have no problem with shear in slab. Our concern in slab only for moment. We don't care about torsion, we don't care about any shear, nothing. So the only two options I will use MZ to get my reinforcement in Z direction. MX to get my reinforcement in X direction. Any questions so far? So MZ. You would like to design how much steer reinforcement. Do you remember to design? We need 1.4 dead load or 1.2 dead load plus 1.6 live load. That's right? So which results you are going to use? Which results? Are you looking for results for surface combination or for strength combination? I think strength combination. First strength combination, just dead load times 1.4. Second strength combination, 1.2 dead load plus 1.6 live load. I will use this one. This one is the maximum combination all the time. So I will select from here strength, load plus live. So I will show up my moment in your slab as color fill, as a contour. I will show you what is the meaning of contour. I'm looking for moment in Z direction, this direction. I'm looking for results of combination between 1.2 dead load plus 1.6 live load. So this one, this one, this one, and this one. Just okay. Here you go. This is nothing. Anybody can read these colors? What do you think about these colors? These colors are contour colors. I'm sorry, what you mean? I mean, what this color is? Safe. Yellow. No, not safe. This color is yellow. Okay, any point in your slab has this color, your bending moment equal 0.47 to 0.99 kib feet. One more time. What is the color for this point? Yellow. Go ahead for this scale. From this scale, for yellow, any point in your slab, like this one, 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 any point in this yellow area has a bending moment value equal 0.472 point, what's this value? 9.99 kb foot. So, what is the value for moment in this area? Any point in this area has a value of bending moment equal from this value to this value. That's right? So I can see any point in your slab, I can figure out what is the value of my bending moment. Any questions so far?
Quick question on how it works on there. Is it always going to split it up into the same number of colors? So, like, say if you've got a less moment, it's going to be smaller sections of it?
Wait a little bit. So right now, I'm trying to teach you how to read this value. How to use this value or how to use these colors in your design, wait a little bit. So, any questions so far? What is the meaning of this one? One more time. This value or this color shows up your moment Z. Moment Z will give you how much steel reinforcement in Z direction, which is horizontal direction in this slab. One more thing, the meaning of these colors. If you would like to read what is the meaning of this color, go ahead. Any color has a range of bending moment. For example, any point has green color. That means any point inside this area will have a moment in between 0.05 to 0.47 kb foot.
So if we were to look at it, that means it's bending up.
What you mean?
That means, like, if we're looking at it, that means it's like going up.
If you would like to use what you learned in structure analysis, you have to learn something like this. At this location, we have a beam, so we have support. At this location, we have a beam. At this location, we have another beam. We have another beam. We have another beams. So your bending moment, something looks like this. In some area, you will find your bending moment is a positive value. In another area, your bending moment will be negative value. That's right? So can you watch for this one, for example? What's the value for this point? Is it negative? So you are here. A little bit at your location of your support, because we have beam here, and your beam is a support for your slab. So what is the color value? What is the value of these colors? Is it positive or negative? That makes sense. Just after, between this support and this support. That makes sense. That's right. So we learn it in structure analysis. If you make strip like this, we learn it. Your slab is supported in your beam, supported in your beam, supported in your beam, supported in your beam, supported on the beam. We learn it, if you have distributed load in your beam, your bending moment diagram, something looks like this. That's right. If you can read, hey, these colors in this area is positive value. These colors in this area, negative value. These colors, positive value. I'm sorry. So negative, positive, negative, positive, negative. That makes sense. So I can say, hey, my results looks good. Any questions so far? We are trying to read what you did. If you would like to show up another thing, we are looking for MX. MX will show you bending moment that can give you how much steer reinforcement in this direction. Let me show you. Just hit OK. Here you go. Your color changed a little bit. If you would like to read, go ahead and get strip in this direction. That's right. Your beam is support to your slab. Support to your slab. Support, support. From structural analysis, if you would like to draw your bending moment, something looks like this. That's right. Go ahead and check what is the value here. Negative. What is the value? That makes sense. So my diagrams, my colors, my value looks great. Okay, so what is the main purpose? Yeah, that's fine. I will print these colors and I will show my results in my calculation. That's great. But how much is steer reinforcement? I would like to learn how much is steer reinforcement. What do you think if I assumed one strip in slab with 1 feet width? I assume I got one strip of your slab with 1 feet width. So what is this distance? 1 feet, which is 12 inch. What is its thickness? 5?